Crafting the glow stick, the genesis of a tube light. Have you ever wondered how a tube light, that long, slender source of light, comes to be? It all starts with a simple glass tube. Imagine a giant straw but made of glass. That's our starting point. These tubes are made from special glass that can withstand high temperatures. They are carefully inspected for any flaws or imperfections. You wouldn't want your tube light to crack when it heats up, would you? Once the tubes pass inspection, they are cut to the desired length. A typical tube light is 4 feet long, but they can be made longer or shorter depending on the need. Now, our glass tube is ready for the next step, coating it with phosphor. Let's explore that fascinating process. Bathing in phosphor from glass tube to illuminated wonder. The inside of the glass tube gets a special coating. This coating is what makes the tube light glow. It's called phosphor, and it's a bit like magic. Phosphor is a material that emits light when it absorbs energy. In a tube light, the energy comes from the mercury vapor inside the tube. We'll get to that in a bit. The phosphor is applied to the inside of the tube as a fine powder. This ensures an even coating for consistent light output. Once the phosphor coating is dry, the tube is ready for the next stage, installing the electrodes. The heart of light, electrodes, and the gas that fuels the glow. At both ends of the tube we attach small metal parts. These are the electrodes, and they're like the starting line for the light. They help create the electrical circuit that makes the whole thing work. One electrode is called the cathode and the other is the anode. When electricity flows through the tube, it travels between these electrodes. But the electrodes alone won't make the tube light up. We need one more ingredient, mercury vapor. A tiny amount of mercury is added inside the tube. When electricity heats this vapor, it emits ultraviolet, UV light, invisible to our eyes. That's where the phosphor coating comes in. It absorbs the UV light and converts it into visible light, creating the bright glow we associate with tube lights. Section 4, from factory floor to your ceiling, assembling the tube light. With the electrodes in place and the mercury vapor sealed inside, the tube light is almost complete. The ends of the tube are sealed with caps. These caps hold the electrodes securely and also create an airtight seal, ensuring the mercury vapor stays inside. Finally, the tube light is mounted onto a metal or plastic fixture. This fixture contains the wiring and other components needed to connect the tube light to an electrical circuit. And there you have it, a simple yet ingenious invention that has illuminated our world for decades. Section 5, the classic bulb. A century of illuminating our world. The incandescent light bulb, that familiar pear-shaped object, has been a staple in our homes for over a century. Its journey from the factory floor to your living room is a fascinating tale of craftsmanship and ingenuity. It all starts with the bulb itself. Molten glass is blown into molds, creating the iconic bulb shape. The glass needs to be strong enough to withstand the heat generated by the filament. Next comes the heart of the bulb, the filament. This thin wire, usually made of tungsten, is carefully coiled and attached to 2 wires that extend down from the base of the bulb. When electricity flows through this filament, it heats up and glows brightly. Section 6, light-emitting diodes, the future of illumination. LEDs, or light-emitting diodes, are rapidly becoming the new standard in lighting. They are energy-efficient, long-lasting, and incredibly versatile. But how are these tiny points of light made? At the heart of every LED is a semiconductor chip. This chip is made from layers of different materials, carefully grown and etched to create a specific electrical circuit. The chip is mounted onto a heat sink which helps to dissipate the heat generated by the LED. A lens is then placed over the chip, focusing the light into a beam. Finally, the entire assembly is housed in a protective casing, ready to be used in a variety of applications. Section 7. Tube lights versus bulbs. A tale of two technologies. Tube lights and bulbs both illuminate our world, but they do so using different technologies. Tube lights are based on the principle of fluorescence, while traditional incandescent bulbs rely on incandescence. In terms of shape, tube lights are long and cylindrical, while incandescent bulbs are typically pear-shaped. LEDs, on the other hand, can be made in a variety of shapes and sizes. Efficiency is another key difference. LEDs are the most energy efficient, followed by tube lights. Incandescent bulbs are the least efficient, losing a significant amount of energy as heat. Each light source has its own set of applications. Tube lights are commonly used in commercial and industrial settings, while incandescent bulbs are still found in some homes. LEDs, with their versatility and efficiency, are finding their way into a wide range of applications, from homes and offices to cars and electronic devices.